I've just got to the Maison du Nom at the University of Luxembourg to meet Sona Salehian Ghamsari, who's going to tell me all about the computer model she's been building to basically predict how ground behaves. We've been seeing so much in the news lately of mysterious holes appearing in roads and things like that. Apparently it's all down to aquifers. I'm going to learn more from her, so let's find out more. Sona, there was a massive news story recently where a huge hole appeared in the center of a road. What caused that?
We have population growth, and then we need more water. And then when we extract more water from ground, then we would have subsidence. And this subsidence can cause like hole or damage of building or this kind of stuff.
So it's because our population is growing, or more importantly, it's because we're needing more water, that these magical, mystical holes just appear out of nowhere. What exactly is happening?
So here you can see we have different layers of formation. It can be like soil or sand or gravel. And then we have groundwater that can flow and move in these layers. And then we'll have like recharging area, like precipitation and this kind of stuff. And also we have discharge area, like a spring or river or pumping wells.
An aquifer, is it really just an area of water?
Yeah, it's like water moving between rocks and soils and sands. You can think of aquifer like a sponge. So it is elastic. When you load it, it deforms, and when you unload it, it returns to the same position. And also it is porous. So when you have water inside, it can move or store in little spaces in the rocks.
Okay, so it all starts with rain. The rain then filters down through the ground. And so there's this whole labyrinth of water flow that's happening underneath our feet.
Traditional research involves the collection of lots of different forms of data. Sona consolidates all of this information into one computer model.
So many maps, and it's all of the same area.
Yeah, exactly.
Showing different
information.
Different
layers, the fracture directions, and faults in the area, and all these information would be as input to our model. And then we would extract like deformation, like this movie that shows the deformation in the region after extracting water from this pumping well, or even other results like flux and pressure of the aquifer system.
So are you doing this research because your computer models are good based on data that's already been recorded, but you just want to make your models better?
With satellite data, we have freeze data, and we have every 6 days almost SAR data, and then we can add to our model.
Where does your research come in then?
So then we use this elasticity theory and build our model. And then we will use an aquifer test to test our model. So aquifer test is like we have a pumping well like this, and then we will pump water out of the ground, and then we'll have observation wells like this one, and then see how the water level change. And with this information, we can estimate aquifer properties.
So it sounds like not only is it expensive to install all of that measurement, but it also sounds like it's very expensive in time.
It takes like maybe 20 days, but it takes time to install, to drill the wells. It really costs a lot. So even if we have like wells in the aquifer, it's more difficult than just observing satellite data.
Every 6 days?
Yeah.
What's your motivation for doing this work?
It was really important when we see like big cities have these kind of problems. So it's good to know more accurately the aquifers. And also fantasy in my mind is we can use also in this method in another planet, because we cannot use like wells and this kind of stuff in Mars, so we don't have information about underground there. We can use satellite data and add them to our models and see what's going on underground in other planets.
Wow, Sona, you have so much work to do if you are trying to build accurate computer models here on Earth, because once you've cracked that, I can see you going on to Mars and doing the exact same work there. Thank you so much for showing me what you're doing. It's fascinating stuff.